Flack math! Give me some math and I'll give you some flack. Flack math!
All right, so we are going to do lesson 83, which is adding vectors. So right now, if you had a vector that looked like this, 2 units plus 3 units, what's that going to be? 5 units, right? Okay, well, that's nice if they're both going the same direction. Now, if they're going the opposite direction, if you have 3 units minus or plus 2 units this way, then that's only going to end up being like 1 unit there, right? So if you go right 3 and then back 2, you're going to end up only going 1 unit to the right, right? This is kind of like adding positive and negative numbers. So this works when it's the opposite directions or the same direction. But what if they're going in weird different directions? Do you need to go? Okay.
Are you recording?
Yeah, thank you.
I also have a question. Would you by any chance be willing to round up Flack attack points?
Maybe. Depends on how your participation is, and it's usually great. So that's a good incentive, yes.
How many points do you need to like get a free problem?
It's like what, 5?
You need 5. So every
I only
multiple
have
of
one,
5.
right?
So you have 1 Flack attack?
How many do I have?
So if you have a 101 and you're in that grade, which is the first grade in your participation section in your grade book. So if you have 101, then you need 4 more to get a free problem
I
set.
have like 110, but I have like 123 in the coupons.
Yeah, and have you seen my note yet that for one of your problem sets you uploaded a practice test instead of a problem set?
Yeah.
So just do it. I'll upload the right thing. I won't mark it late. Just
Okay.
Just
yeah, I saw
upload
it and I was like, okay, that's perfect. So I just need 6. That way I don't have to do school the last 2 weeks.
okay.
That was my
All right. So you have added vectors that are in the same direction or opposite directions, but now what happens when you have vectors that are directions are not so simple? Okay, so we're going to do the parallelogram method. So parallelogram method means draw a parallelogram with the 2 vectors from the origin. So for example, if you have a vector that's doing this and this, so here's vector V and here's vector W. So the parallelogram method says this: draw a parallelogram like that, and then this is your resultant vector, is when you do the diagonal. This is V plus W, right there. And it kind of makes sense because you have to go up this much and then over this much, and you end up right there, right? So it's the diagonal. You end up right there because or you can go this way and then up V that way, and you end up right there. That's the parallelogram method. So let's do an example. Here's example 1. So use the parallelogram method to draw this. So component vectors. So we're going to go A. The vector A this is in component form. So that means you would draw a line from the origin to that point. Okay. I'm going to add A, which is that, plus B, which is this, 4, -1. Okay, so we're going to use the parallelogram method. Okay, so the first one, A, looks like this. A is 2, 3, so it goes right there. Everybody okay with that so far? That's where A is. I'm going to sneeze inside my mask because I can't take it off. Ew, gross.
Can't we like have
Wait, was that the first time I ever heard you sneeze? I think
Maybe.
it might have been.
You have a dad sneeze.
Do I?
Yeah.
So my brother, when he sneezes, he goes, "Sugar." I don't know why he puts a "ga" on the end. Sugar. Sugar. I wanted him to say "bless you," but whatever.
Bless you. Oh, wait.
Sugar. What?
Do you have to look at the light to sneeze?
Yeah, if I'm on the edge of a sneeze and I can't get it out, then I look at the light and then I,
That's what I do, and I used to think I was allergic to the sun. Yep.
yeah. Technically, everybody's allergic to the sun. If that was the
Really?
yeah, because yeah, it's not.
If
It's
you
too strong.
sneeze when you look at it.
Okay, let's look at 4, -1. How do we draw that? We'll go over 4 down 1. So this is 4, -1. So if I draw a parallelogram, let's see here. Boom, boom. So here's B. So if I draw a parallelogram, and obviously it's a lot easier when it's on graph paper. But let's do that. So we're going this far and then this far. So from here, you're really going up 3 and over 2. Let's see. So maybe that equals 6, 6, 2. Okay, do you guys see another way to add these vectors? Besides just drawing a parallelogram? What?
I mean, you just add them.
Yeah, you just add them. Look, what's 2 plus 4?
6,
What's 3 plus -1?
2.
2. So you're just adding the vectors. Okay? So that's just, you don't have to graph it. You can just add the vectors. All right? There's another thing called head to tail method. Basically, you're just following when you end one of your vectors. So here's the head, here's the tail. So you put the head of V on the tail of W, and you go in the direction of V. That's the same kind of thing that we did, right? So the head to tail method is, let's just write that down just in case you're asked about it in your homework. Head to tail method. So here's W. Here's W. And then here's V. Okay? And then this is your W plus V. All right? So this is the head. This is the tail. Here's the head of V and the tail of V. So you put the head of V on the tail of W and then keep going. All right? This is what Siri would do, the head to tail method. Okay, go that way for this long, and then once you're there, go this way for this long. Okay? All right. But you're really just adding those coordinates. So if you know the coordinates, so like this, they don't give you it in coordinate coordinate form, or component form is how we call this. So you just draw. You have to draw it, and then you have to draw that length there. So you're just at the mercy of your own artistic abilities in this case. Okay. All right. So the other option is with trigonometry. Okay. So let's say that you want to add these vectors here. Let's say A, which is 6, 1, and B, which is 0, 4. Okay? And let's say you don't want to know just where they end up, but you want to know what direction this goes. So if I were to graph this, 6, 1 would be 1, 2, 3, 4, 5, 6, and right there. And 0, 4 is right there. So if I'm going to 6, 1, and then 0, 4, basically left to right 0, and then up 4. So it goes up to here. So here's 6, 1. And then this is 0, 4. And then I'm looking at this guy here. And where is this? Where this ends up at 6, 5. Okay? But what if it says add the vectors and find the magnitude and direction? So we just found where it ended up. But I want to know what this is. I want to know the magnitude and direction. Okay? So how do you figure out the magnitude? How do you figure out how long it is? How long is that blue line? Yeah.
Distance formula.
Yeah, distance formula. And the cool thing is the first point is 0, 0. So it's just the square root of 6 squared plus 5 squared. So if you draw, so ignore the vectors that we did to draw that. Now here's my new triangle. Okay? What are the dimensions? Well, 6 and 5. So far, so good? Pythagorean theorem or distance formula says square root of 36 plus 25 is the square root of 41. So that's the magnitude. All right, now I need to know the direction. So what angle is this? So this is my theta. I want to know what angle this is. That's my theta. How do I figure out theta?
One of the functions.
Yep. Okay. So what 2 things am I given? Actually, I'm given all 3 now. I'm given square root of 41 there. But what would you use to find theta? There's like 6 options, but if I wanted to find theta before I found that, and I'm just given these sides, what are these sides in relationship to theta? Opposite. 5 is opposite of theta, right? Across the pond. And 6 is not the hypotenuse, but it's one of the sides of theta. So it's adjacent. Okay? What's opposite over adjacent? What trigonometric function is that? SOHCAHTOA. What's opposite over adjacent? Which one? Tangent of theta equals 5 over 6. So far, so good, right? So all I have to do is figure out what 5/6 is, okay? And then I have to inverse tan theta. So to get theta by itself, we're going to inverse tan both sides. So somebody do that on your calculator. So theta equals the inverse tan of 5/6. So if you're using an iPhone, remember you do 5 divided by 6, and then you hit the inverse tan button. Or if you're having a regular calculator, you just go inverse tan, and then it'll put a parenthesis there, and then you go 5 divided by 6, and then enter. So if you're using an iPhone, remember you have to do it sideways. If you're not using an iPhone, what do you have, Kate? What is that?
An iPhone.
Okay, so yeah, you'd have to go sideways. So what'd you get, Janae?
9 point.
Does that look like 39-ish? What'd you say?
39.8.
39.8-ish? Let's see what the book says. So they said, oh, you know what? I did it wrong, but that would have been right. I think I copied the problem down wrong. So that's 6. That should be 6, 0, not 6, 1. Sorry. But yeah, that's the idea. Okay? So if they ask for just the component form, then yeah, just add these, add the x's and add the y's and you're done. You don't have to do parallelogram method or whatever. I mean, that's just all silly because if you're given the components, just add the x's and add the y's. Okay? But if they ask for direction and magnitude, then that length, that vector length in component form, this does not tell you the length of this vector. This kind of tells you the length of the vector because it's just a vertical line. Okay? But if the vector is a non-zero here, non-zero here, then in order to get the magnitude, the length of that, it's the square root of the sum of those squares. Okay? But the direction, you're going to have to use some trig. All right, let's do let's do one more example, and this is actually the real life example. I know I try to stay away from real life, but who knows, you might have to do this math problem sometime in your life. A plane has traveled a horizontal distance that can be represented by the vector 8,000, 0. So see how that's a horizontal distance. So for example, on my coordinate plane, here's 8,000. Coordinate plane, get it? Plane, okay. All right, so this is the vector. This is the vector 1. This is where the plane traveled. 8,000 and then 0 up or down, okay? And a vertical distance represented by the vector 0, 4,000. So this is 0, 4,000. Okay, so up here, that's 4,000. So I want to know where the magnitude of both vectors is measured in meters. What is the magnitude of the distance it has traveled to the nearest meter? Okay, so obviously this plane had to take off, right? So this plane had to take off, so it's doing this. I want to know the magnitude and the direction. Okay, does that make sense? So see if you can do this. See if you can do this. Finding the magnitude and direction of this vector, this dotted line. So, my mom every Easter makes deviled eggs.
I love deviled eggs. I can't make them. I don't want to know what's in them.
Okay, but the problem was they were bad eggs. So guess what? Half of my family gets to say today. I've had diarrhea since Easter. Yeah, that's from Nacho Libre. It's like one of my favorite movies. I've had diarrhea since Easter's.
Weren't you Nacho Libre sit up like one Halloween?
I hate mustard.
I was there when you did that.
No.
Little cake.
Oh, I hate mustard. The smell, the texture, the
Weirded out
color.
by that
I
black
hate
food.
I hate mustard.
I just realized that this morning, so I texted like my family and said, "Hey, guess what? You get to say this for reals."
I'm gonna be sick of thinking about it straight up.
Mustard.
I don't like any mustard. Absolutely not. The color, the texture, the smell, everything about it is horrible.
My wife hates mustard, and now over the years, I've grown to dislike it as well.
Yeah, it's because it's horrible. Ugh, sorry.
Yeah.
I hate mayonnaise.
You know what I really hate is like the fancy mustard, the Dijon or whatever.
With the flakes.
Ew.
It's
No, I
horrible.
just don't like. No, I hate like the cheap, like crusty mustard that everybody like has pulled out at barbecues and stuff.
Yeah.
Sorry, even like the thought of it like makes me ill. Anyways,
In the McDonald's.
So, what do you guys want to do first, direction or magnitude?
is there like a formula?
Yeah, well, you could figure it out. I bet you could use your gut to figure out what that length is going to be and
600.
what this angle is going to be.
I'm not just gonna email 600.
I know you've had a spring break, so you're a little rusty.
I was 60
And you've been in the bathroom for the last 10 minutes.
Yeah, I was
probably
watching
because you've had diarrhea
TikTok.
since
I
Easter.
really didn't want to come back.
Okay,
You were so on.
what should we do?
Yeah, I just sat there.
What should we do?
Is it 10?
Is it a 60-degree angle? That's
No,
You
so
know-
not just half a 90, it's a 45.
Kind of like a
angle.
good guess, but remember it's a 60-degree angle only if this is twice as much as the
Isn't it
short
like
one.
So it's a
it's
45
half a
degree
90?
Well, it's a little bit less. What?
I said it's half a 90-degree angle, but that's not right.
Well, it doesn't look quite half, but what are for those of you who weren't pooping in the bathroom the last 10 minutes,
Yeah.
what should we do?
I was just watching TikTok.
That just sounds wrong.
Yeah, it happens.
You're just.
I had no emotional will to come back.
Jilly,
That's, I didn't.
what do you think?
I don't know. Like divide 4,000 by 8,000 and like saving above.
Yep, so if I wanted to find this, that's tangent of theta equals opposite over adjacent, so katoa. So 4,000 divided by 8,000, I'm just gonna say 0.5. Everybody okay with that?
Yes.
Because that's what 4,000 divided by 8,000 is. So inverse tan, so theta equals inverse tan of 0.5. What's the inverse tan of 0.5? Okay, so theta equals 30.6. Now we've got our direction. Now we need our magnitude.
That might be.
Okay, don't overthink this. How do you find the magnitude, Janae?
That might be wrong. So.
This might be wrong.
Well, I did 4,000 divided by 8,000 and then inverse tangent. It says 38.6. Did I do that right?
I got 26.5.
So 0.5,
4,000 divided by 8,000.
I just did like 25.
and then inverse tan of 0.5. What'd you get?
I got 26.5.
Okay, should we go with that?
Yeah.
Okay, so 26.5. Now we need to know the magnitude. You can do this, guys. How do you find the magnitude?
Distance formula or.
Distance formula or Pythagorean
Oh,
theorem?
that.
Yep, so that's a big one. So what is that, 16 million plus 64 million, and then the square root of that? So what's the square root of 16 million plus 64 million?
Here's a problem. I do numbers until it's Me too. And then my brain mixes up the zeros.
So what's the square root of 80 million?
I guess I can. How many zeros are in 80 million? Is the question.
Is it 7? 80 million?
Yeah, what's the square root of 80 million?
How many zeros are in 80 million?
6 or 7, because if you include the
Wait,
AT.
Can I?
So 8 and then 7 zeros, square root that sucker.
Wait, hold on. I can't find my phone and then I'll square it.
It is 4,000 radical 5.
Is it?
Yeah.
I got 8,000.
Oh, yeah, you got it in radical form. That's nice. What'd you get?
8,944.27.
190999. See, I like it in radical form better.
It's more exact.
Wasn't there used to?
All right, so that's about 8,944 feet. That makes sense. This is going to be a little bit longer than the longer leg. That makes sense. Okay, any questions with 83?
Absolutely. Great lesson.
It was great.
That was like, that hit me. That's like, you're not on spring break anymore.
Yeah.
Not even earlier, except for, here's the thing, my senioritis. Through the roof. My cousin and her boyfriend's senioritis is so bad. They can still do anything. I already
Doesn't do anything. He doesn't do anything. They got into college and they're like, that is so lucky.
I'm at the point where I've saved up all my free problem set, but for the last 2 weeks of school, I have no intention of doing any homework.
Well, see, that's what we talked about. because then you're not going to get
But I'm never
practice.
going to use geometry again.
You might major in math.
Yeah, you are on the last freaking test. So
I have no intention
don't-
of taking that either.
No.
Wait, what's
All right, I guess that makes sense.
25th.
Yeah, because like if you're gonna have an A in the class, then, like I have a feeling I'm pretty confident because I'm gonna do good on this next test. I'm like,
Okay, we're going to talk about dilations. What's the first thing that comes to your mind when you talk about dilations?
like when you dilate your eyes.
What's the second thing that comes to your mind?
10 centimeters. If you got children, you know.
Yeah, the second thing that comes to my mind is when pregnant women talk about it, and I'm like, do you realize what you're talking about? Don't say that in front of men.
That hurts so
It's
bad.
gross.
Sometimes I think about
Are you
that.
dilated? Oh, okay.
What's all over your hand?
Did you like burn yourself?
Activated.
This is what happens when I use this. Okay? It gets dirty, but it's more effective than this.
I think it was like why?
Okay,
why
so
did
guys,
people had a 10
Not guys, but girls, when you get pregnant, please don't have these conversations with people. I mean, other pregnant women, yeah, they kind of get it. They're in that zone, but don't say the word dilated ever. Okay?
I want to stop.
If you don't know what that means, don't Google it. You won't be able to eat
I like
tonight.
so I think I
Okay.
should
It's gross. All right, it's gross. So dilation, now in this context, it's just going to make the whole lesson awkward. But dilation means making something bigger or making something smaller. Okay? So you're not changing the shape, you're changing the size. Okay, so there is a scale factor. So a dilation that results in an image smaller than its pre-image is called a reduction or contraction. Okay, a dilation that results in an image larger than its pre-image is called.
It's not worth it.
I can't.
What's it called?
Hey, you brought it up.
I know, it's
Trash
your fault.
I'm just gonna write it down, okay?
No, it's not any better
You
because then
started
it's
it.
going to be sitting there on the board.
So we already did this reduction.
I knew it.
Okay. Increase.
Got the whole line.
I have to say my dog. Yes.
Stop it! Stop it!
You did this to yourself.
I know I did.
Okay, does it have to be the word enlarged? Really?
Okay, dilations require a center and a scale factor.
Yeah.
So the center of dilation is called the center of dilation.
What?
Okay, so for example, if you had like a shape here, and then if this was the center, then everything would just be, you would increase or enlarge. You double the size of each. Then this one goes to here. This one goes to here. Okay, and then this diagonal could go to here. So then here would be your dilated object. So there's obviously lots of geometric properties that you can think of there. There's some parallel lines. But the scale factor. So this is like a scale factor of 2. So you double each side length. Okay. All right. Actually, the examples uses this triangle here. So this triangle, so this is not, so like if this is the center of dilation, but it's not even a part of that triangle, okay? So what you're doing is you're drawing from the center that length and then twice the length, And then from here, you're drawing, from this vertex, you're going twice the length of there. So here would be your new dilated shape.
Wait, that's actually cool if you look at it. Like,
It is cool.
No, you trust your head.
All right, so let's do example 1.
This way's not as cool. You go this way. It's cool.
So find AB, find image of AB. So we're going to have a line
You ever
segment
seen
here.
Mary Poppins?
What's that?
Who hasn't seen Mary Poppins?
Yeah, what kind of weirdo are you?
Everybody's seen Mary Poppins.
I've seen like 2 scenes. It got boring. I've only seen the super alifragilistic That's all I've seen. And
I like
a little
it really
girl
good.
with the braids.
Find image of AB with scale factor of 2
I grew up watching that. I hate the Jungle Book too.
I don't love the Jungle Book. I
at
like
center
the-
C. Okay, so here's the center. So see how the center is not like in the center of a circle or center of anything. It could be any point. Okay, so the scale factor of 2, what does that mean? Well, we are going to draw a line from C to each vertex
Wait, I just did
and then
this.
double it. So here's where B prime would be. And then draw the same line, twice as long. Okay, and here's where A prime would be. Then here is our new A prime, B prime line segment. That's not terrible, is it? Okay, see if you can do this. It doesn't have to be neat. Try example 2 here.
I'm actually really excited. This is kind of fun. Not that math isn't fun all the time.
I think I just did this.
It's just this is a very exciting thing.
So apply a dilation to triangle JKL using scale factor of 1/2 and center C. So in order to do this, they have to give you a diagram, okay? So you're gonna have a triangle. Let's say the triangle looks like this. Okay, this is JKL. We'll just put JKL. Center C, let's just put it over here somewhere. Okay, so see if you can sketch that. And this time we're going we're just going 1/2. We're not going times 2, we're going 1/2. So what does that mean? Okay, see if you can do it. So obviously it's going to shrink half the size.
Wait, this is reduction.
Yep, or a contraction.
Wait, now I'm confused. Did we do the shrinking one?
Not yet. We are shrinking it now.
Oh, what's your name?
One day, can you do my initials to like do one of these angle things? Like you know how it says JCK?
My initials are kind of ugly.
KEB.
Yeah, I
I
will.
think those are my mom's initials.
Those are your mom.
Yeah. Your mom's name is Jennifer. I was like, J. I was like,
How do I make it smaller?
my initials are kind of ugly, so I never.
Well, instead of going twice the distance, you're only going to go half the distance.
Oh, I know how you have. Okay.
You guys do that?
I got it.
You just don't want to. Whatever.
I don't even know where my math book is. I had it over like spring break and quarantine, and I just lost it somewhere in my house.
You
Is
know
that
that
empty?
I didn't give you a math
No,
book.
my math notebook.
Oh, okay.
That's where my
I was like,
notes are.
I lost it. I think I lost it at the beginning of
No,
the year.
it's fun.
Is that it? Did I do it right?
Does it look like the same thing except half the size? Yeah, kind of. Yeah, good job. So here's what I'm gonna do. I'm just gonna draw a line from C to J
Okay.
and then cut it in half. So there's where J prime is, right? I'm gonna draw a line from C to L, cut it in half. There's where L prime is. Draw a line from C to K, cut it in half. There's where K prime is, and then connect the dots. That's cool. It looks like half the size.
Really proud of myself. Change that here.
This is not bad, is it? Can you guys handle this?
Yes. Oh, it's kind of like when you never mind. That doesn't make sense.
So this is just sketching. Obviously, you can get real exact, measure with a ruler, cut it in half, and do it that way. You can even use a compass. Remember how to bisect the segment with the compass, where you draw the arches and then connect the intersections. That's awesome. But let's do one more example. This example is doing this on a coordinate plane. So they're going to give you the coordinates, and you have to dilate it and give the new coordinates. Okay? So we're going to apply a transformation. So triangle DEF has vertices at D at 4, 6, B at 6, 2, and C or F, that's a D, sorry, E at 6, 2, and F at 2, 4. Okay, so I'm going to try to be as exact as possible. So 4, 6, 1, 2, 3, 4, up 6. There's D. 6, 2, over 6, up 2. There's E. 2, 4. There's F. So here is what DEF looks like. Okay, now here's the dilation. So here's the dilation. We're going to graph the image after a dilation centered at the origin. See, center is origin. And then scale factor is 1/2. Okay? So this is just like we did before, except we're doing it on a coordinate plane so we can give the exact result. Okay? So if this goes to, if we're going to F here, what's happening in that line is going over 2, up 4. So what do you think the dilation is going to go? Instead of going over 2, how much do you think it's going to go over? 1.
Oh,
And instead of going up 4, how much do you think it's going to go up?
2.
2. Okay? So the dilation is going to be, so the F prime is going to be the coordinates divided by 2. Right? All you're doing is cutting each coordinate in half. So this guy is, let's see, that's 4, 6. So cut it in half, it'd be 2, 3, right? So this is D prime, which is 4 divided by 2, 6 divided by 2. So just cut each coordinate in half. And then E is 2, 4. No, F. No, we already did F. So E is 6, 2. So instead of 6, 2, we're going to cut 6 in half and 2 in half. So this is E prime, which is 6 divided by 2 and 2 divided by 2. So 3, 1. Okay, so here's our new triangle. So new triangle, triangle D prime, E prime, F prime. D prime is, cut it in half, 2, 3. And you don't even have to graph this. E prime is 3, 1. See how I'm getting these? F prime is 1, 2. All I did was cut each X coordinate in half and each Y coordinate in half. If this was the scale factor of 3, what would D prime, E prime, F prime be? What would D prime be if we had a scale factor of 3? Yep, so what would D prime be?
12.
12, 18. You guys see how we got that? All right, that's it. All I'm doing. So the application I'm just going to read just so you, so on photocopiers, the student wants to scan and enlarge a piece of art that is 6 inches by 8 inches. If the student selects 150% enlargement function, that will, what will the lengths of the size of the copy be? So basically the scale factor is 1.5. So you just multiply 8 by 1.5 and 6 by 1.5. Okay. All right. That's it.
Flack!